So this lesson refers to connectivity matrices. You may have heard them referred to as adjacency matrices during year 11. And a connectivity matrix or an adjacency matrix is a matrix which shows how the nodes of a network are connected. If we have a look at this example here, the network alongside shows us the nodes A, B, C, D, and E. The arrows represent the flow of direction. So we can see that both A and B are connected. However, we can see that B is connected to C, but C is not connected back to B. What we can do from the connections is then create our one-step routes. So if I look at A, there is no possible route to get back to A. So we place from A to A, we place a 0. If we look at the connection from A to B, there is an arrow showing one-way flow to B. Okay, so therefore in A, B, we can put the value of 1. If we then go on to from A to C, so A to C, we can see that there is no one-step route between A and C, so we put a value of 0. The steps A to D, once again, there's no one-step route, so we put the value of 0. And from A to E, there is a value of 1 because we can see a one-step route from A to E. We continue this process for the remaining of all starting and finishing nodes. What we can see is we have this leading diagonal. What a leading diagonal means is there's no route from A back to A, no single one-step route. We also have this row of zeros at D. What this is saying is that once the connection gets to D, that's its endpoint. So you can see that there's no arrow then taking off from D. Once we've shown a table below, we can actually rewrite this table so it's in the form of a matrix. So for a connectivity matrix, in this case we label that matrix with the value of C. And we can see that the values of 0 and 1 inside the table are what form our matrix. So I'm going to go through a couple of examples. So in these examples, we're going to look at the connectivity matrix for each network. So if we have a look at the first example here, part A, okay, we can see it has 4 nodes. So therefore, when we eventually set this up, our matrix will be a 4x4 matrix. To start with, what we're going to do is actually write the start and finish so that we're aware. So we've got our starting nodes are A, B, C, and D, and our finishing nodes are the same. A, B, C, D. When we look at our node A, there's no loop around the node A, so there's no connection from A to A, so we put a value of 0. From A to B, we can see one edge joining A to B, so that becomes the value of 1. But from A to C, there's no connection, so that becomes a value of 0. From A to D, there's also no one-step connection, so that also becomes a value of 0. Alright, and that's our first row completed. We then repeat the same process for the remaining nodes. So from B to A, there is an edge, so that's represented by the value of 1. From B to C, from B to B, there's no edge, but from B to C there's 1, and B to D there is 1 as well. From C to A, 0. From C to B, there is 1. From C to C, there is 0. From C to D, there are 2 edges. From D to A, 0. From D to B, there is 1. From D to C, there are 2. And from D to D, there is 0. What we notice here is if we held a mirror along these values of the 0, there is a mirror reflection of our placement of the values. We also notice, okay, that if we look at the sum of the rows, okay, so row A has a sum of 1, then that tells me there is only one edge coming from A. Okay, whereas if we look at row D, that's the sum of 3, so I can count 1, 2, 3 edges coming out from D. All right, from here, we can now just represent our connectivity matrix. So our matrices are always labelled with a capital as well. All right, so it would be 0, 1, 0, 0, 1, 0, 1, 1, 0, 1, 0, 2, 0, 1, 2, 0. Okay, and then we put a square bracket around the end of it. All right, so that's for a connectivity matrix where there's no direction. Our next example looks at where there is a direction. Once again, our starting and finishing points, we can record that down. So we're going to use P, Q, R, S, T. I'll just spread it out a little bit more. And then it's also from P, Q, R, S, T. All right, so we're going to start at P. We can see from P to P there's no connection, so 0. From P to Q there's also no connection, so 0 once again. From P to R, still no connection. So our first connection is from P to S, and we can see that here the arrow is pointing to the S as well. Okay, it's a two-way connection, so we can put a value of 1. And from P to T, we can also see that single arrow going through from P direction of T, so that's also a value of 1. If we look at Q, we can see there's nothing to P. We also don't have a loop, so we can get rid of the Q. We actually don't have that connection. R is pointing to Q, not the other way, so we also have a 0 there. And then from Q to S, we can see that arrow is pointing towards the S, so that's a value of 1. And Q to T, once again, the arrow is pointing to the Q, not the T, so that becomes a value of 0. All right. So I'll keep following this process, and you can check at the end to make sure that I've got them correct. So I usually say it out loud, so R to P, 0, R to Q, 1, R to R, 0, R to S, 0, R to T, 0, S to P, 1, S to Q, 0, S to R, 1, S to S, 0, S to T, 0, T to P, 0, T to Q, 1, T to R, 0, T to S, 1, and T to T, 0. Okay, so that now completes our table of values. So our connectivity matrix, once again, is the same. I think I've spread this one out a bit more. Okay, so it's really important that you copy the values down correctly. Okay, you can see we've got that leading diagonal still as well. And we've got that finishing spot here. So after this work, what I'd like you to do is just sticking to our day plan for our outline is have a look at the questions dealing with connectivity matrices on page 246. 247, sorry, they start, so the example's on 246. Just questions 1, 3, 5 and 7 from the textbook.